Greetings to all. I hope my presentation slide is visible in all your machines. Yes?
Yes,
Yes,
sir.
sir.
Okay, thank you. Thank you. Okay, so in today's session, we are going to discuss about the recursion example. In our previous session, we discussed about recursion, how to implement recursion using how to implement GCD using recursion. Okay, greatest common divisor using recursion concept. Then the towers of Hanoi problem we discussed, and then we discussed Fibonacci series, how to implement Fibonacci series, how to find the nth Fibonacci term using recursion concept. Okay, these three algorithms we discussed, and the example programs also, the programming implementation also we discussed in our previous session. In today's session, as I already told, we will discuss about the conversion. Okay, the expression conversion. There is a prefix expression into postfix expression, how to convert it. Okay, so whatever the mathematical expressions we are writing, that format is called as a infix notation. Okay, so in infix notation, the operator will come between the operands. Okay, that is what infix notation. Suppose if you are writing an expression a plus b, it is an infix notation. Okay, what is a prefix notation means? We will write the operator before means the prefix, and after that we will write the operands. That is operator, after that operands. Postfix means the operands will come first, then operator. Advantage of prefix and postfix is same over infix expression. Okay, so in prefix and postfix notation, we need not worry about the operator precedency and associativity. Okay, so evaluating an prefix expression and postfix expression is easy compared to infix expression. In infix expression, if you know the operator associativity and operator precedence over other operators, then only it's possible to evaluate infix expression. In prefix and postfix expression, it is not required. Okay, so that is what advantage of a prefix and postfix notations. Okay, so I'll try to explain this algorithm. Okay, so and we will see the implementation, implementation of this program also. Okay, you execute this program and check it, and from exam point of view, this question is not that much important. Okay, because if any question is asked related to conversion, prefix to postfix or infix to postfix means, mostly they will ask you to the implementation mostly expected using stack side only. Okay, so using stack perform the conversion operation, so that we will study in the second unit. Using recursion, the conversion from prefix to postfix is less importance. Okay, so let us check it here. So this is let us take this expression. Okay, minus plus star abc divided by ef. So this is the given prefix expression. Okay, what is our objective is, from this expression we need to find the postfix notation. Okay, here what we need to do means, first we need to find one operator, and following an operator, two operands we need to find. Okay, whatever the operator is coming, each operator, assume that we are going to process only the binary operators, and each operand size is only single character. These are all assumptions before this discussion. Okay, we are going to discuss about only 4 binary operators: plus, minus, division and multiplication, and each operand is 1 character length. Okay, a is one operand, b is one operand, c is one operand, e is one operand, and f is one operand. So each operand length is only 1 character. These are all some of the assumptions. Okay, so here our aim is to find an operator following the 2 operands. Once we find this operator and the 2 operands, then we can move the operator after the operand, and we can ensure we can find the postfix notation. Okay, so this given prefix notation can be written in a tree format like this. Okay, so first we need to find a star a b, an operator followed by 2 operands. So star a b. So leftmost, if you are looking at star a b, the innermost expression we identified. Now the star a b, it is a sub expression. It is added with the c. So the next level of expression is a plus star abc. Okay, and then rightmost expression slash ef. Okay, then combining this minus plus star ABC slash EF. So here our objective is find, because finding the length of the expression is important here, because one operator and two operands. Here the operand itself may be another expression. So what is the length of the left operand? What is the length of the right operand plus one operator? That is what the total length of an expression. So to find the length of an expression, we will use one more recursive algorithm. Okay, so this is the general idea. You can write the given prefix expression or postfix expression into a tree like this. From this, it's possible to convert one form to another form easily. Okay, now I'll just make one simple correction. Okay, so these are all the steps we are going to follow. Okay, to design the algorithm, we need to find the operand. Okay, because the operand may be a sub expression. Okay, so finding an operand, so we need to there is a general case, then sorry, that is a base case. General case is finding the left operand, finding the right operand, and finding the operator. So then combining these three into a expression, okay, as a postfix expression. So this is what our objective here. Okay, so here in the algorithm is given here. Suppose if the prefix expression contains only one operand, okay, directly we can move it to the postfix expression. This algorithm contains two parameters. Prefix in, it is one character array. Postfix in, it is another character array. Suppose if the prefix in, its length is only one, it means that it contains only one character, one operand. Okay, so that we are directly moving to the postfix expression. If it is not, then the first character will be an operator. We are moving the first character to the operator, it is a variable. Then we are finding the length of the expression, okay, total length of the expression, and then we are finding the postfix expression 1 and postfix expression 2. So postfix expression 1 means left hand side the first operand. Postfix expression 2 is the second operand, and finally we are combining postfix expression 1 plus postfix expression 2 plus operator. So postfix expression 1 is one operand, postfix 2 is the second operand, and we are concatenating with the operator. So this is what we are going to implement. Okay, and here we are calling in the line number 4, we are calling find expression length. It is one recursive algorithm. Okay, that algorithm calculates the length of the sub expressions. Suppose if an operand is not a single character, okay, if it is not, it is a sub expression, then its length we need to find. For that purpose, this find expression length, this algorithm is used. Okay, so this is what that find expression length operation. Okay, so please make a note of it. In your book, suppose we are referring the book, in the book, here it is given as a length 2, expression in plus 1 plus length 2 it is given. It is not length 2, it is a length 1. In the previous step, we are calculating length 1, and in the next step, we are using the value of length 1. So length here in this example, we are calculating the in this algorithm we are calculating the length of the sub expression. Okay, so in detail as a means a process flow diagram, it is given in the next slide. See here, this is what our objective. See here, length of the prefix expression equal to find expression length of prefix in plus 1. Okay, prefix in plus 1 means, see here, line number 4, length of expression equal to find expression length. This is what from means this line is explained in the diagram. Okay, this line is expressed in this diagram. Okay, so prefix to postfix, so this is the input expression, prefix expression. Okay, then we are for this expression, what is the left expression length, what is the right expression length, we need to calculate. Okay, so here we are passing prefix expression in plus 1. What is the meaning of this plus 1 means? Exclude the first character. From the second character onwards, calculate the length. That is what the meaning. Okay, so why we are excluding the first character means, first character we know that it is an operator. Okay, in any prefix expression, the first character will be an operator. So we need for that particular operator only, we need to find the left sub expression and right sub expression. So except that first character, from the second character onwards, start finding the sub expressions and its length. So this is what objective. So it is going to this find expression length. So for this algorithm, okay, so this find expression length algorithm, expression in for this variable, we are sending except minus, okay, except the first character, the rest of the values are passed to this algorithm. Okay, so now in this algorithm, if the first character is operator, okay, first character is operator means it is a sub expression. Okay, it contains more than one character. That is what the meaning. So we need to find length 1 and length 2 using recursion. So except the first character, from the second character onwards, so expression in whatever the input coming plus 1, from the second character onwards, again it's recursively calling the find expression length. Okay, see here, find expression length, expression in plus 1. So for the next level of call, it is going star abc/ef. Again, since the first character is a star operator, again recursion is going a find expression of abc. Here the first character is not operator, it is a operand. Suppose if it is a operand, it will go to the else part. In else part, what we are doing, a length 1 length 2 equal to 0. Okay, so here length 1 length 2 will be assigned as a 0 and returns 1. Okay, so what is the value returned is return length 1 plus length 2 plus 1, that is 0 plus 0 plus 1. So that will be returned. Okay, this will return 1. The same way length 2, it will return 1, and finally this recursive call will return 3, because 1 plus 1 plus 1. Okay, length 1 1, length 2 1 plus 1, totally 3 will be returned for this expression. What is the meaning of the 3 means? Okay, here minus plus star. Okay, for this plus, the sub expression is star abc. Okay, star abc. So this is the left expression for the plus. Okay, so that is what the length star abc, its length is returned. Now length 2 for plus, what is the right hand side operator? It is a c, its length is a 1. So that is what returned here. Okay, so once you identified the length 1, okay, once you identified the length 1, okay, what we need to do means, okay, we need to find the second string. Okay, so the length of the second string we need to calculate. Okay, so that is what we are doing it here. Find expression length of expression in plus 1 plus length 1. Okay, length 1 we calculate as a 3. Okay, so in this input, except the first character, 3 characters star a b, we need to leave all these 4 characters and the remaining cef is passed. In cef, the first character is operand. So length 1 length 2 will be assigned to 0, and length 1 plus length 2 plus 1, it is a 1, so returns 1. So we are returning 1. So in this input expression for plus, left side expression is a star abc, totally 3 characters. Right side expression is a c, 1 character. So it is returned as a 5. Okay, now this 5 is a left side expression, sorry, 5 is the length of the left side expression for the input expression. Okay, input expression is a minus. Okay, for minus, the left side expression is a star ab, means a star b plus c, totally 5 characters. Okay, that is what left side expression for minus. Right side expression is a e divided by f, 3 characters, that in the next recursive call it will invoke. Okay, so this procedure may look like difficult to understand. Just to go through this example, this diagram. Okay, if you understand, if you are reading this diagram means you can understand a little bit. Again, I am saying you already know what is a recursive function and how it will work. Okay, based on that, you try to explore this concept. This is not that much very important from exam point of view. Okay, now let us see the implementation. So the same algorithm here we converted into C program. It is also given in your book. Okay, as it is, I am using it here. Okay, so find expression. This is the find expression algorithm. Okay, and this is prefix to postfix. From here we are calling the find expression length. So this we are calling, and finally we are copying the left expression into postfix, the right expression into postfix, and then operator into postfix. Okay, so for this algorithm we are passing two arrays, one is prefix and one is postfix. Finally the postfix array contains the postfix expression, and we are testing minus plus star abc slash ef. So this is the expression we are going to test. Let us check it. See here, the prefix expression is minus plus star abc slash ef, and the postfix expression is abc ab star c plus ef slash minus. So whatever the operator comes in the first, it will come in the last in the postfix expression. So this is the implementation, C implementation for the prefix to postfix conversion, a recursive implementation. Okay. Now in your book, okay, so in exercise they have given some programming examples. Okay, so how this recursive program will work, how this, what will be the output of this particular algorithm, recursive algorithm, like that, how to solve this kind of algorithm or this kind of problems, that we will see now. Okay, so in the first chapter itself, means in the basic concepts, we discussed about the recursion. Okay, so recursive example, see here. So in this way only we need to solve such kind of algorithm. Okay, in each version of the algorithm, what is the parameter value and what it returns. If we are writing like this, then it is easy to solve the problem. Even means without any confusion, we can easily solve the problem. Okay, now let us go to your programming exam, that exercise. Okay, so here the first problem given is, they have given one algorithm, and for this algorithm, if you are passing for 4, what will be the output, and if you are passing 10, what will be the output, and if you are passing 12, what will be the output. So they have given it like this. Okay, now let us check it how to solve this problem. Okay, see here, function 1 of 4, this is the parameter value, and it will go to the algorithm. Okay, in algorithm 4 is a parameter value. If 4 is less than 5, okay, since this condition is true, it will go to the first state, true part. Okay, it will not execute the else part. In the true part, there is no recursion, directly it is returning the result. There is 3 into x, the x value here is a 4, so 3 into 4 is a 12. Okay, and 12 will be returned, that is the result. So this is for the first exercise, function 1 of 4. If you are using the 4 as a parameter, this recursive algorithm, it will give 12 as a result. Okay, now we are passing 10. Suppose if you are passing 10, then how this algorithm will work? Let us check it. See here, now function 1 of 10, we are passing 10, it will go to the algorithm. Now 10 is greater than 5, so the true part will not be executed, it will go to the else part. The else part is a return 2 into function 1 of x minus 5. Here x value is a 10, so 10 minus 5 plus 7. So here a recursive function call, again it is calling the function. So again we are writing the function. So 10 minus 5 is a 5. So 5 is passed as a parameter. Function 1 of 5. If 5 is less than 5, return 3 into x, else return the formula 2 into function 1 of x minus 5, that is 5 minus 5 plus 7. Now here 5 is not less than 5. Okay, if the condition is less than or equal to, then true part will work. But in this case, it will go to the else part. Now in else part, 2 into function 1 of 5 minus 5. 5 minus 5 is 0. So for the, again it is a recursive function, function 1 of 0. We are passing the 0 as a parameter. Okay, so 0 will come as a parameter. Okay, so function of 0, function 1 of 0. If 0 is less than 5, yes, 0 is less than 5. Now the true part will be executed, not the else part. Okay, so here it returns 3 into 0. 3 into 0 means, that is 3 into x. Since x value is 0, it returns 3 into 0, that is 0. So 0 will be returned to this function call, because from here only we are invoking the function, the algorithm, using 0 as a parameter. So whatever this algorithm, the last algorithm, it returns, the return value will be passed to this function call. So 0 is returned. So 2 into 0, that is 0, plus 7. 7 is the result. Now the 7 will be returned to this function call. Okay, because we are passing a 5 as a parameter to this algorithm. So whatever the result of this algorithm, it must be returned to this function call, function 1 of 5. So 7 is returned to here. Now 2 into 7, that is 14 plus 7, 21. So 21 will be returned to the main function call, function 1 of 10. So 21 is the result for the second option, means the second program. Okay, second exercise. Now the same way, try function 1 of 12. All of you try, please reply in the chat window. Function 1 of 12, you try. Yes, C was correct. The answer is 45. Okay, so in this way you can solve the recursive algorithms. Why we are discussing here means sometimes there is chance to ask such kind of questions. So please go through the exercise, the exercise problem sets given at the end of each chapter. Okay, and discuss with your friends and try to solve such kind of problems. Okay, it is important. Okay, so this is what our first unit. So we completed our first unit. So in first unit we discussed pseudocode. What is a pseudocode and how to write pseudocode, how to write algorithm using pseudocode, then ADT, abstract data type and its models, and then recursion. Okay, what is a recursion, how to solve GCD, factorial, Fibonacci problems using recursion, that we discussed. Then we discussed about a searching problem. Okay, so using arrays, how to implement sequential search and binary search problems, then hash search problem. Okay, in hash search we discussed about collision resolution techniques also. Okay, after that we discussed about sorting. So in sorting we discussed about two types of sorting, bubble sort and selection sort, and the implementation also we discussed. So this is what our first unit contents. Okay, so whatever the topics we discussed so far, in that if you have any doubt, please post your doubt. Otherwise we will move to the second unit. Any doubt so far? Rahul, prefix to postfix, you are not clear. Yes, correct. Okay, so again, in this mode, in this way mode of teaching, okay, so it's difficult to explain in detail. So I shared the algorithm code and I explained a little. Okay, please go through the diagram. Okay, so without the diagram, okay, so without the length of finding the length of the expression, okay, without understanding the diagram, it is difficult to understand that two algorithms. Okay, please go through the diagram. Okay, still if you are having any doubt means we'll discuss it in the next class. Kayati, so what is your doubt in collision resolution technique? Please exactly tell me, then we'll discuss. Which technique you are unable to understand, because it contains many techniques. If you have any doubt in specific technique, otherwise please go through the video once again, then ask the specific doubt, we'll discuss. Don't ask revise his entire topic or entire chapter once again. Okay, thank you. Okay, since no doubts asked by many of you, so we'll move to the next topic. So our next unit, our second unit, what we are going to discuss. So first we'll see an overview. So in second unit, we are going to discuss about the general linear list first. Okay, so general linear list, here it is a linked list. Okay, so generally we are going to create a linked list. A linked list is an linked list is more or less equal to arrays concept. Since array is static, it is not possible to increase the size of an array in runtime. Okay, and arrays has some limitations. They introduce the concept of linked list. So we are going to create a linked list in our second unit, and using the linked list we are going to implement stack. Okay, stack is one data structure. Okay, and queue, we are going to implement queue operation. Okay, queue is another data structure. So first we will create a general list, and using the general linked list we are going to create stack, and we are going to implement queue operations. And finally the complex implementations in linked list itself, there are different versions of linked list available: circular linked list, doubly linked list. These are complex implementations of linked list that we will see at the end of the chapter. And then applications, okay, using stack, infix to postfix conversion, and the evaluation of postfix expressions. And for queue, categorizing data. These applications we are going to discuss in the second unit. So this is what introduction to the second unit. Okay, now just as an introduction part, we'll see what is a linked list. Okay, so in linked list data structure, okay, so we can change the size of the linked list dynamically in runtime. Okay, so you can add a new data into the list, you can delete a list. Okay, so the insertion deletion operation requires less execution or less operations compared to array. In array, inserting a value or deleting a value will take more time and more functionalities. But in linked list, the insertion deletion will take less number of steps. Okay, it may be difficult to understand, but once you are understanding means the process is very easy. Okay, so as part of this data structure course and these linked list operations, we should be very thorough with pointers concept. Okay, because we are going to use the structures and pointers in the linked list, and examples also we are going to discuss using pointers concept only. Okay, so please recap the pointers concept once again before coming to the next class. In next class we'll see the programming example for all these linked list concepts. Okay, so here successive elements are connected by pointers. If it is an array means for array memory will be allocated continuously, contiguous memory allocation. So the first data is in first address space means for sure the second data will be in the next space and the third data will be in the next space. So easily by adding the integers, means by using the index of array, we can easily access the array elements. Okay, but in the linked list concept, every time we will create the data using dynamic memory allocation concept. So when the first time we are creating a data, okay, that memory location, and for second data, whatever the memory we are creating, that location, it may be independent. One data location is independent of another data location. So we need a way to access all the memory locations that we are creating. So for that, what we are doing in linked list concept means, whenever you are creating a new memory location, its address you are storing in its previous memory location. Okay, so means we are by storing the address of one data in the previous one, okay, we can able to access all the data. You can see the diagram here. So A is our first data, B is our second data, C is our third data. A, B, C, all the three are in different memory location. Okay, how to access A, B, C all means we need not remember all the addresses. We need to remember only the address of A. Okay, then B's address will be stored in A and C's address will be stored in B. Since we know the address of A, after printing or processing A, using this address, we can go to the B, then process B, then using the address, go to C. Okay, so in this way, we can access all the elements in the linked list. In linked list, the last element, okay, the last element's address value, okay, it will not, since there is no more elements, it will be pointing to the null. Okay, this is what introduction to linked list. Okay, here the first node, okay, it is called as a head node, or we will create a special structure node which is called as a head node, and it will contain the address of the first node of the linked list. Okay. Okay, now to keep track of linked list, we must know the start node or head node, the address of the first element. Okay, and the linked list provides flexibility in allowing the items to be rearranged efficiently. That is, insert an element is easy, delete an element is easy. Okay, so this insert operation, delete operations, we will see in our next class clearly. Okay, how we are going to create this linked list means, see here if you are taking A, okay, A is nothing but it is a structure variable. If you want to create an array means, normally we will give int array of means int values of some 100, so 100 values will be stored. But here A is a separate variable and B is a separate variable. Okay, this A variable contains address of B. Okay, so this together is called as a one element, means a data part and address part. Data part and address part combinedly called as a one node. Okay, so this is called as a one node A. It contains a data part and address part. Okay, it contains the address of a same type of node. If you're taking B and A both are same type. Okay, both contains the same type of data and the same type of address. So this address is called, so this is called as a self-referential structures. See here, type diff. Okay, so type definition we'll discuss later. So as of now, just think about this structure. Struct node, it contains struct item data. Okay, and struct node star next. Okay, struct node, the structure name itself is a struct node, and one of its value means a structure member also struct node star next. Okay, it's a, since we are using star, it is a pointer variable. Next is a pointer variable. It is pointing to the address of struct node, means same type of structure variable. Okay, so here instead of struct item data, you can give integer roll number, or you can give integer roll number, character array of name, CGPA. Many data items you can keep it here. Otherwise, you can keep that all the three values as a separate structure, and that structure variable you can keep it here. Both examples we will see. So this is how we need to create a single node structure. Once we created a single node structure, then we can start creating the linked list. Okay, so that implementation and all we will discuss it in the next class. As of now, just understand the basics of linked list concept. Okay. Any doubt so far? Any doubt so far in the linked list concept? Any doubts? Okay, fine. Okay, if no doubt, we can end the session again from Monday, means next week onwards. We'll discuss about the second unit, that is implementation of the linked list concept. Stack.
Sir.
Yes.
Sir, by using address which is in A, we are
Hmm.
pointed to B now, sir. At a time we can point to B and C.
If you want to point B and C means you need to have two address fields in the same structure itself.
Okay, sir.
Okay, since it is a linear list, after accessing one node, we need to access the next node. One by one only we need to access. So
Okay,
go to A, from A go to B, and from B go to C. This is what linear. Okay, from single node, if you are trying to access a B and also C means it is a non-linear data structure that we will discuss in the third unit.
Okay, sir.
Okay, okay. Any doubt? Okay, if no doubt, we can end the session, and next week we'll discuss about the linked list implementation concepts. Thank you.
Thank you.